Hello, this is Danica Dvorak. My partner is Jordan Stevens for this. He recorded our Homework 16 video, so I'm doing our Homework 15 video. This homework has 3 parts, 6.3, 6.4, and 6.5, so I'm going to try and go through this pretty quickly. But the first part is the European call. This is referring to the European way of doing stocks, and the way that the stock market works in Europe is different than the United States. I don't have enough time to go into that, but just know that that is true. Here in this MATLAB code, the 100 is the current price of the stock, the 97 is the stock price, so when the seller is selling it, and then the 0.05 is the risk-free rate. The 103 divided by 252 is how many days until the stock can be sold. So 252 is the amount of trading days in a year. And then 0.2 is the volatility. So it represents about a 20% variance. So this is our MATLAB code for that. And when you run this code, the call ends up being 7.84 and the put ends up being 2.878. Going down to our next one here. Oh, and you know what? Sorry, this should say 6.4, my bad. But for this one, this is estimating that European call, but with Black-Scholes. This is like a formula for that European call. So for this one, this over here, this yellow portion, that's from our book, from the appendix that the problem is coming from. And this is our MATLAB code that it is kind of referring to. So here, let's run it really quick. This is the function, but when we come down here, this is the MATLAB code that's going to call that function. And so here we're doing 10,000 runs. 126 minus 23 is 103, which is what we had in the last problem. So that's where this 23 is coming from. And then all the other numbers should make sense from our previous one. So here, when we run this, our call ends up being 7.86, which is very similar to our call from the previous problem. The upper control limit here is 7.94, and the lower control limit is 7.77. Moving on to our actual 6.5, which is delta hedging. Once again, this yellow over here is the part from the appendix from the book, and over here is the actual MATLAB function that we've created for it. And then this is the function that's actually going to call that other function. So when we run this, we can run it by calling a couple of different things, but here what's important to know is that 700 here, Hedge 700, that's the stock price. The 0.05 is the risk-free interest rate. The 0.03 is the continuous interest rate. The 0.1 is the volatility. 0.5 is the time in years, so about 6 months. And N is the number of times that this problem is hedged. 680 is the starting price, and 0.15 is the expected growth rate. So we can run this and say, like, we can do 1 and then 10,000. And when we do that, our answer is about 13.358. But yeah, so that is how we did those different problems in less than 5 minutes. So hope that helped, was educational, and we'll be back next week with more homework problems.